The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
God.
It sounds amazingly exciting. That's all right. This week, I had some really funny guys at the class I was doing. The one kid, Monday we talked about like what they wanted to learn and stuff, right? And Tuesday, because I asked him, I was like, you guys have a job tonight. Are you guys going to be in the morning? He's like, oh yeah, I'm a machine. I was like, all right, cool. Then so we'll see you at 7:00. Fucking didn't roll through the door until like 7:20.
7:00. That's like break time almost.
Not for class. So anyway, machine didn't fucking show up until 7:20, and then there was another kid who looked like he was 12 that literally like the first day he was late, and then the second day he was late. I was like, did mom have to drive you? Like, did she not pack lunch? Did she have to write a note? Did she have to kiss you goodbye? And we were like, he was an electrician, and so they were practicing brazing. And he's like, can I take this home? I was like, yeah, are you going to put it on your fridge for mom? So it's late. I hit traffic, so sorry for, being so late. But
yeah, I don't care. I was angry downstairs, getting ready to smash my computer.
Oh, we'll talk about that in a minute. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. Here are the hosts, Brett Wetzel and Kevin Compass. Yeah, so what happened to your computer?
I don't know. I went to go pull it out this morning to program a bunch of cases, and it just blue screen to death. And I'm like, oh, you gotta be kidding me. I just used it the night before.
Stop leaving it in your freaking car.
Listen, if I can't leave it in my car, there's no point because I'm not going to remember to grab it every morning.
Put it next to your wallet. Put it next to your Glock.
I leave my wallet in the van too. I live in the middle of nowhere. Nobody steals anything out here.
There's nothing that you take. Put it next to your keys. Hook your keys up to a computer bag so you can take it out there so it doesn't stay in your freaking cold ass truck. And then when it warms up, when you start it up, then it doesn't end up breaking the fucking thing.
No, because then it's just going to do the same thing during the day.
You take it into the freaking store with you.
Why would I take it into the store with me? I don't use it all the time.
Then why do you leave? Okay, never mind. I'm not.
I just need it when I need it. I don't use my computer on every single call.
Surprising.
Or like every single startup. Like half the time if it's an E2, half the time I'd rather just do it on the E2.
Very true.
I mean, if it's an E3, like I'd much rather have the computer. It's way faster. Like, and same with Danfoss. Like anything with a touch screen, I'd rather have the computer.
So what else you got going on this week?
Oh, I was doing a bunch of CO2 startups, and then I had my CCM 30 for the third time. This is the third rack in a row where I've had a CCM 30 bleed through.
Bleed through like it wasn't sealing all the way?
Yep. No matter what you do, it just won't seat all the way. And so I was hoping to get this one overnighted, and I don't know what the hell happened, but it didn't. So I started up on Monday, and I had basically no load, couple walk-in coils, real low load. Mm-hmm. So it was bleeding through no matter what you did. You could hear it moving, and it would open wide up. Like if you could open it wide up, and you could tell it was open wide up, but it would not shut no matter what you did. No matter if you drove it with the iPro, no matter if you drove it with the handheld, it wouldn't shut all the way. Pulled it apart because I've had the motors come unscrewed. Pulled it apart, re-zeroed it. Nothing, same thing. Well,
Hunter Liberty sells them.
yeah,
No
and
shit.
they have everything that's like for anything important.
Okay. I was just like surprised.
Yeah, I'm about to order one to keep in the truck because it's been a ongoing issue. To be honest, I'd much rather just throw a CDS 7 in there and be done with it.
7 or the Switchblade 9.
Yeah, I mean the 7's pretty close to a 30. If you look at the sizing chart, they're pretty close.
Do you have a United States sizing chart for Danfoss stuff?
I don't, but I crossed this over a couple years ago with them with Sporlan, and the 7 came out pretty good. But the 7s are also rated for higher pressure.
Really?
Yeah, a 9 is rated for much less pressure than a 7. So a 7 can handle if they have the 860 reliefs on there for the backups if somebody leaves them, the 7 will take it. So what I did in the meantime, since I had real low load and I couldn't build pressure in the flash tank no matter what, so I couldn't push liquid out, I was hosed. Instead of leaving, what's up?
Can you up the? Did you up the subcooling?
Yeah, lowered. You mean?
Well, depending on how you look at it, like up it to me like from like 5 up to like 3.
I made the number less. We'll say
that's what I'm talking about.
Yes,
it's so confusing because you're like subcooling less. You're like what?
I made the number less, and yeah, it does help a smidge, but when you have no load at all, like, and I got the old 30 horsepower VFD special, so yeah, don't put it on the 10 that's in there. Let's put it on the biggest compressor.
Well, I think it's it's that scared factor.
It really grinds my gears.
No, I know. I had to someone made a phone call because we made some adjustments to some other things. We took some coils off of the door switch because when they would get delivery in the middle of the night, when the delivery driver would have the door open for, I don't know, an hour, the rack would just keep dumping because the all night from like 8 o'clock at night till just about the open, the VFD is sitting at nothing. Like it's sitting at its min percentage. And unfortunately, the ZZ rack that they have in there has hot gas injection. But my fear is the suction temperature, because the mass flow so low, it's only 68 degrees. Is already 68 degrees. So you put hot gas on there, it's gonna.
Dude, those hot gas injection valves in those zero zone racks rip.
Well, and that's my fear because it did raise the pressure like instantly, but then to follow, the temperature started shooting up really quick. So
dude, it ain't like the advancer racks with that smaller orifice. Like that zero zone one rips.
So my point being, like, so the only other thing we could do was now invasive. So either downsize the compressor, right? Basically make it smaller. We could raise the head pressure a little bit, whatever. But then the only other thing you could do is put liquid injection basically in there, right? To counteract the hot gas so you don't cook the freaking suction line, cook the windings. You're muted. I don't know why you're muted.
Can you hear me now?
I can.
I don't know. I moved the roadcaster and it freaked out. I don't know.
You're muted again. What the hell? Nothing. I can pause it and let you re-come in if you want. Here, let me pause it. And why it does it is because you are incapable of not breaking computers, apparently.
No, I just moved the roadcaster and it just disconnected from everything. Cool. All right, so I don't know why Zero Zone isn't they don't put liquid injection on their racks.
So this is a conversation I had with Bob because like Bob's like super against. He's like, well, if you engineer it, to where it's going to be, you shouldn't need it. Okay, and to a point. To a point. So like if you figure in then, okay, well, how about them having night shades? How about them getting deliveries in the middle of the night, dropping off, 56 MBH or some shit. You know what I mean? Like these are kind of things that are unforeseen, but that would still be nice to have in case that shit happens.
Then the rack engineer says, well, that's not my problem. I size it to a rack load and the case people are evil. Blame them. And then the case people say the rack people are evil.
And the rack people aren't evil. It's the,
It's the energy people that are evil.
energy people. Awful.
But no, so like
energy.
back to my thing. So I couldn't build pressure. I couldn't build oil pressure. I couldn't build pressure no matter what I did.
Okay.
So I have a few super small racks.
Throttle the ball valve?
Yeah, I didn't want to do that. That's kind of ghetto. So what I did is in the iPro, you could set a minimum percentage for the HPV. Now,
yes.
What this does is this keeps the HPV at a minimum percentage. As long as there is no safety situation, like the receiver pressure gets too high, then it will start shutting back the HPV. So what I did is take a minimum of like 25% and shoved a shit ton of gas in there. Now, like the subcooling value was kind of out the roof at that point. It was kind of all over the place because it's ignoring the subcooling value and trying to maintain that 20%. And to be honest, it loaded up my medium temp compressor enough to keep the drive compressor running at like 30, 40% instead of sitting at minimum. So to be honest, I think I may do that in all my part load startups from now on. I may keep that HPV at a minimum just to keep the rack running and keep it, steady.
That's kind of comparable to a gas cooler bypass.
It had gas cooler bypass. It didn't do shit.
What? Really?
Yeah, it didn't do shit. There was that little. There was 2 dairy coils, a small little cooler that was brand new that came down to temp in like 8 minutes, and a produce coil. So like I had 3 coils. I mean, with walk-ins, everybody thinks walk-ins are a big load. They're not. Walk-ins aren't shit when they get down to temp. You have load for a little bit, and then your load's all gone.
Yeah.
So without cases, you don't have that constant air infiltration. Like, yeah, the walk-in in the morning had a ton of load, and then in the afternoon when nobody was in there working, had nothing.
Yeah, I get you.
So I'm not a big fan of these gas cooler bypasses on the Blemo 3-way valves. I hate them. They're so slow. They're so slow. It reacts so slow to the PID. Well, it's 90 seconds almost for it to stroke.
Yeah, it's usually anywhere. Like I've seen them at anywhere from 90 to like 100. It's even in some of the bigger ones. It's like 150 seconds where it takes to stroke.
How do you PID tune something that's got a mod motor that moves that slow? Your PID already needs to be kind of slow for the gas cooler bypass as it is, but like I couldn't get anything out of the like gas cooler bypass, but also you can grab a discharge line because it had so little load.
Yeah, no, I get it.
Well, I mean, it was really nothing at that point. But I will say this: the HPV minimum kept the rack moving because it's not so much about the gas cooler bypass. Is putting it there is you need the flow more than anything. And if you don't got the flow, you're done. And it's just going to keep constantly short cycling. And you don't want it to short cycle because that's when you start pumping the oil out, and you're not going to get your separator, cycles. And on hill. And most of the other ones, they're looking at compressor proof in order to drain the oil separator. So that's where I was getting into. Like, it wasn't proving the compressor long enough. It wouldn't get enough runtime on there to prove the compressor to drain the oil pot.
Yep. No, I get you. I get it because it doesn't want to transfer that energy over to the reservoir to transfer it over to the flash tank because then if the compressor ain't running, theoretically you just keep popping the flash tank, and that's the reason why they tip it. I mean, that's why I think they prove it. Or you have a different thought about it? I'd like to hear it.
No, I mean that you don't want to just pop in the flash tank artificially, but it almost like in a low load startup scenario like that, you're kind of hosed unless you know what to do. Like I had to end up forcing the oil solenoid for a while, just to get everything moving and draining.
Well, I mean, some people have made suggestions, especially if you're doing like a rolling remodel where you hang on, like put a freaking evaporator on near the rack. Like you literally just put another false load, outside and just run it.
We've talked about that. I've seen other people do it, but like honestly, I think this minimum gas cooler pressure or the minimum
HPV opening.
Yeah, HPV opening works just as good without adding anything else. I think the minimum HPV opening works just as good. I mean, it's still running right now. Like I think by the time today I got the last medium temp load on there, I think the BGV was calling for 10% open at this point.
Yeah.
and I was past my minimum on the HPV. So I
Mhm.
mean, it was back rolling. Obviously, it should have been, closer to like 30% is where I usually see these.
Mhm. Mhm.
But I mean, it's keeping the rack loaded, and that's what we needed.
Gotcha. I mean, the other thing you could do to add load, but you had a hard time controlling your thing as it is, by raising your flash tank pressure, right? Because by raising your flash tank pressure, you basically reduce the amount of net refrigeration gain. What dictates that is the actual temperature of the actual flash gas versus whatever your saturation is. So, a friend of ours, had a problem where he lost a low temp compressor and he didn't have enough low temp compressor to finish the startup. So what I had him do is drop the flash tank pressure just for the time being to basically get more net refrigeration gain. So instead of having a flash tank that had like 38-degree liquid, I think I had him drop it down all the way down to 30. By now dropping it down to 30, the difference between the saturated suction was essentially, 32. I think I had him boost the suction up to -10, but basically 40 degrees rather than 60 degrees. So, it's just like how a subcooler works, right? It creates less flash gas if you lower it. Well, same thing if you go higher. The higher the temperature of the flash gas, of the flash tank temperature versus the saturated, if you make that higher, basically you reduce the amount of net refrigeration gain, which means you make the compressors a little bit, work a little bit harder.
Yeah, I mean, the only problem is you could starve the medium temp out a little bit.
No, you're still no. Yes, but like what I'm saying is, if you didn't have enough load, right, and you wanted to try to create more load, like on your evaporators downstairs, basically increase the flash tank pressure, which would give you more load, hopefully on your medium temp. But you said you barely had two things rolling, right?
Yeah, dude, I literally, it was a dairy cooler that was already at temp before I started.
Shit.
Yeah,
Was
I
it
mean,
just satisfying then?
oh yeah, it was just satisfying, and it was hosed.
Did it have like the adaptive superheat where like it basically started like moving the superheat higher based off of that, or no?
It was XM, so I mean, it was just closing down the valves on temp. I mean, it was hosed. There was nothing. I floated the suction way up. I mean, there was nothing you could do. It was hosed.
Shit.
I mean, it didn't have any load until the next day. We ended up putting like another 24-foot of meat case, and then I mean now it's pretty good. It's got all the medium temp cases on there. It's keeping a compressor running. The 30 horse sometimes hits 45 hertz.
You got to go back when next week?
Yeah, next week we do the frozen. So next week should be a lot better. Frozen, once you get the frozen on there and we get the low temp rolling, there should be more load. But like honestly, like they need to redesign these racks that are getting used in these live remodels. They have to have a smaller VFD compressor. Like I mean, you got to design it for the conditions it's going to be in, not this magical condition that nobody ever sees. When you design a rack for one day a year,
But that
I
one
mean,
day a year, it's got to cool down. No, I agree with you.
I mean, at that point, yeah, no, I mean, honestly, I think that works great. Doing that is doing that HPV minimum trick. I don't think I'm gonna false load racks anymore with anything else besides that.
So remember, every single one of these racks, rack controllers, as far as the CO2 controller, it doesn't matter if it's pack controller, it doesn't matter if it's microthermal, it doesn't matter if it's the iPro, even Corral, it's going to do what is the most highest priority, right? So the safety features, under like a pressure transducer failure or a high pressure failure, or it's a high pressure failure on the on the discharge line, it is still going to shut down the high pressure valve down to 0%. It's not going to ever forget that. Essentially what, because I've seen this happen too before where there was a problem with gas cooler fans. And, as we talked about before, the HPV, when it's running subcritically, it's supposed to be controlling subcooling. Well, it doesn't want to drop that pressure down below like a certain minimum. Well, we had an instance in Texas somewhere where, the pressure was getting lower than what the minimum was supposed to be. So just like he said, it kind of said, screw the subcooling set point. I don't really care about that. I just want to keep the rack running. So it basically went to its minimum pressure. Kevin essentially did the same thing. The only difference is he just gave it a minimum percentage to run rather than a minimum pressure.
I've been seeing that a lot lately with the rack pressure with minimum and the fan pressure minimum being crisscrossed.
Mm-hmm.
Yep, and they're fighting each other. Like
So you explain that in a little detail then.
okay, so this is I see it a lot on the advancers. You'll have a drop leg set point of like 45 degrees, and you'll have a minimum set point in the iPro, say like 800 pounds.
Oh, hold
Like,
on. What is 800 pounds? I forget off the
I
top
don't know.
of my head.
Get the fucking.
Oh, I got to do it. Okay, all right.
You're
So go ahead.
Jamie. So you'll have, for example, say like you'll have a 45-degree drop leg temp to run a condenser,
Mm-hmm.
and you'll have like an 800 or 900 pound minimum pressure in the iPro.
Okay, so hold on. Let me just get this out first. So 45 degrees is about 594. So let's just call it 600, okay?
Yep.
Okay.
And you may have like an 800-ish pound minimum pressure in the iPro.
Okay, and that's essentially 66.5 degrees.
So
And this is extremely comparable to almost like your fans and your holdback valve on a regular HFC rack, yes?
they're fighting each other. You're
Correct.
literally fighting each other. And this is common on a lot of the older advancers. I see them, and then I see them on a lot of the CO2 racks where they all run this super low. Like everybody's like, oh yeah, run low condensing, but then it's not low condensing because you're basically just stacking a ton of CO2 on the roof. Like you get these random low liquid level alarms when it gets cold, and you get these. It runs like complete dog shit at this point.
So just like, the high pressure, I'm sorry, just like a regular HFC rack, where typically our fans have a min of, let's just say 70 degrees saturated. And let's just say our holdback valve, our A8 would have maybe like a 60 degree, saturation holdback. So same thing with the fans with the TD, we have a minimum gas cooler outlet temperature that we're trying to maintain. So, let's just say for that instance, let's just say we call it for the fans, let's just say we call it, 66 and a half degrees, which is 800 pounds. Okay. For the fans. Then if the wind is still blowing and it's cold as shit outside and that air is still rolling, then maybe we go down to maybe 700 PSI on the HPV minimum, which would be 56.6 degrees saturated or 700 PSI. And then that way the holdback, or I'm sorry, the oh my God, too many terms. The high pressure valve, the HPV, would then start acting like an A8 valve.
Yeah, in this case, it would be a holdback valve. Now,
I know, but I just back and forth.
okay, so in this instance, and I've seen a lot, there is a low fan cutout pressure inside of the E2, inside of the E3. Then I've seen that set like anywhere from 800 to 900 pounds. So like you have these three conflicting set points that are all just fighting each other. Because what happens is you hit that low fan cutout, boom, all the fans are off.
Mm-hmm.
Okay, but your set point's still real low. So as soon as you come back above that pressure and above the hysteresis,
That was good.
Shut up. As soon as you come back above that hysteresis, then bam, all the fans come on full blare, and you're wound up already on the PID for the fan loop. So it's just this constant up and down, up and down, up and down, and then dude, the condenser when it's running like that is just hammering the rack. It affects everything. With a CO2 rack, it starts at the gas cooler, and that's where all your crap run comes from, is the gas cooler.
Today's episode is sponsored by the RefRush RDP series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
So my personal thing with this is drop leg control for the fans sucks. It sucked when they used it on DX. When they stopped using it, like SCT control is so much more stable. Using saturation pressure converted to temperature and running that off a delta is so much more efficient than running it off drop leg temp. Like when we switch it, it instantly calms the rack down.
That's what ZZ does. They do that on their stuff.
I've been doing it for forever. I've been converting every rack that I go to that I have
about it forever.
Yep. Like it runs night and day better. Drop leg temp control is awful. I mean, if you were in Texas, it'd be fine. But like where you get cold like us, I mean, the instant those fans come on, it just goes.
It gets cold. It gets cold in Texas.
It does not get cold in Texas.
You bitched the other week that you were down here.
It was a long time ago.
No.
It was cold, and you were in a Carhartt coat, and
that was another time. And I only came because I was
in a face mask
because I was incognito.
And you were cold. And you were cold.
Fuck you. I was hiding. You're such a dick.
But I honestly, that's where that crap control comes from. And the same thing with part loaded racks. Like when they're controlled off drop leg temp, they run absolutely horrendous. They just run horrendous.
People are gonna be so mad at you for even saying that. There's always like 4 people that are like, they've been doing that for years.
Why though? They stopped. They did it with racks back in the day in the 80s.
Didn't work. It didn't work well.
It didn't work well then. But why? Because it turns to a different subcritical fluid that nobody knows what it is at that. But like at the same time, just turn the fans on 100% by then.
I don't know. I don't get it.
And it's still got some liquid in there. Remember that R9 rack with the sight glasses?
Mm-hmm.
So
still a mystery. Still a mystery.
But at the same time, yeah, I mean that's a good fix for that. I'm about to start moving some of these VFDs to the smaller compressors.
Well, they probably would have been fine if the 2 other engineers that were stamping off of it didn't have to upsize it by about 5% to save their ass. Oh, it's right there on the borderline, 5%. Next,
I will say this: I'm super stoked. 5%. Super stoked. This rack actually has the Westermeyer strainer in here, and not that high deck one that I just want to smash every time I see it.
The one that was it backwards?
No, it wasn't. I took it apart to make sure before I pulled the vacuum.
Really?
Well, yeah, because like it's deceiving.
Mm-hmm.
But now they got the ChargeSecure on here, and there's a lot more valves on here that around stuff. So
around what for what?
So I had one the other day where it had ChargeSecure on it, and the oil solenoid was stuck.
Oh no!
So I just swapped
the one that was at the ChargeSecure, or the one that was
the one that was the dump.
Oh.
So it's stuck closed. Well, so if you have ChargeSecure,
they have one on there.
They have it. There's another solenoid next to it. So all you got to do is swap the coil.
Yeah, isn't there? There's actually a solenoid that goes over the high pressure valve.
So I had to look at this because I was like, what the hell is this thing? Like I was opening this rack, and this rack unfortunately is like 6 feet in the air on steel. And
you probably could energize that solenoid to get more load.
So then the opposite. So there is a solenoid around the oil. Okay. There is a solenoid around the high pressure valve. There's a solenoid on the suctions. So what they're essentially doing is when this thing goes into fail-safe mode or whatever, the ChargeSecure sees it, a high pressure situation, it's turning on, energizing the solenoids, it's pulling off the top of the flash tank, and it's discharging back into the beginning of the oil separator, and it's pushing through, and it must be this so small they're using convection on the gas cooler, whatever it is, to cool it down, and they're going around the high pressure valve and back into the flash tank, and then repeating the thing. It's like a constant loop. It's the smallest little baby. It's literally like the size of this water bottle, but fatter.
No, it's teeny tiny, and it has its own little VFD. It's the most adorable VFD you'll ever see.
It's like this little tiny ABB VFD, little baby.
It looks like it's just a display of like a Danfoss. Like that's how small it is.
Yes, yeah, it literally is the size of the display of the Danfoss. Unfortunately, mine doesn't run right now because we were missing the power supply. But
The power supply.
Yeah, it runs off a battery.
Yeah, the only thing I don't really dig about that is the fact that I don't know, like, why fucking drive? Like, why put a drive on something that's supposed to be saving your unit?
Yeah, for default out, because the drive's doing the enable for it. It's doing all the math, and that was, I don't know why the controller isn't just controlling it. Let the controller do it. I mean, it should just fail on. But I guess, I mean, at that point, you need fancy stuff to make it work. I think Costco does it the best way still. Backup condensing unit, bare bones, no controls on it, just on if the rack fails, and it's on a generator.
Yeah, no, I don't have that. I thought I had it. I was going to bring up what the ChargeSecure looked like, and I thought I had.
It is fairly simple. Once I started tracing it all out, because I thought something was up with that with my flash gas bypass valve, because I was like, what the hell is going on? Then I'm like, what is this line? Tracing that out.
Yeah, I was trying to figure out why the whole thing with the thing and the thing, like where, I don't know why I was like, what's the solenoid around the high pressure valve? That's weird.
Because it needs flow.
No, I know that, but I'm saying, like, when I first saw it, before I saw the ChargeSecure or whatever, I was just like, oh, that's why.
Yeah, no, it's definitely a lot more piping around stuff, but I dig this second oil solenoid. It's real nice when it plugs up, so you can just swap it to the other one. It's like the Carlisle oil filters.
All right, well, someone out there wants to send me a P&ID of the ChargeSecure, because I thought I freaking had one in the schematic. I literally thought I had one, and now that I switched over my phone, I can't find anything. So awesome.
So I got to rebuild this flash gas bypass valve. I'm going to try to rebuild it instead of cutting it out, because it's in a really bad spot. So I don't know if anybody's ever taken apart one of these CCM 30s, but you need what looks like a drag link socket, but it's also a gigantic Allen key, but the center has to be honed out. So if you take a rod coupling, a 3/8 rod coupling, and kind of clean it up on the edges, it fits into this like fairly nice. And then if you weld the socket on the end of it, you can get the orifice out, because when you unscrew the motor, it only unscrews the motor. The actual piston assembly is still inside of the valve, and it's screwed on internally.
Here we go.
Yeah, look, see, little baby. It's not even the 3-phase.
Yeah, it has the three phases, the 3 fuses there.
Yeah.
So that's what the electrical cabinet looks like. There's the itty teeny tiny compressor.
Little baby.
Little baby. And then there's the check valve. Yeah, check valve there.
The only thing that pisses me off is they shoved it in the flex pack.
Yeah.
It's tight.
And then there's that's right, because I took a picture of this. This is the bypass around the high pressure valve. Oh, little itty baby.
Yeah, so you have that little dial to turn if you're trying to make it work.
5 minutes turn past.
Why 5 minutes? Like, you ain't doing nothing in 5 minutes.
I just want to make sure it's running. That's it. That's all I'm doing. Dude, I swore I had the fucking schematic and shit, and like how this thing was in the actual flow diagram, but I don't. So I won't.
It's in a very bad spot inside the flex pack.
Yeah, it kind of is. It was the one I was up in one of the northern states where we think they're, I don't know. Yeah, that's the one where they give the automatic is to you for the engineers. You just give your participation fee.
You just get your participation trophy.
Mm-hmm. That and when you go up there, you get like a trailer and a couple cars, but you're in your front driveway and shit.
Stop it. The end of my week, we just did a bunch of Danfoss drives yesterday, put a bunch of drives on a rack and digital compressors, and starting up these drives. And for some reason, we got these smoke detector drives, the exhaust fan smoke drives. I don't know how these got ordered, but this is like the third or fourth condenser change out these have gotten ordered on. And they show up, and there's like 3 or 4 different renditions of these Danfoss cabinets. One of them has this Danfoss dashboard. One of them's 120 volt control or 208 control, which is awesome. It's easy. And one of them's got this MK06 bypass board. Now, this one, for some reason, is set up for smoke exhaust fans because it's got all these fireman controls on it. Like fire, there's no bypass. The bypass is all internally. So you got to figure out how to wire the bypass. Well, to make it work off the controller, you have to do this fireman's bypass. And I had one where the bypass wouldn't work. So inside the drive cabinet is get the drive. Right underneath it is the attached bypass cabinet. It's all built into one. So it's all one big unit. They put the fucking contactors behind the 460 fuses and disconnect.
Why?
You can't even get to them. You
Why?
can't get a meter lead in there. You can't get anything. You cannot get your hands behind it. If you try to go over like this, you have exposed fuses at the top for the drive. You have the main fuses below you. You can't get your meter lead in. You can't even see if the contactor is pulled in without a mirror.
Didn't you send me that picture?
Yeah. So I had some auxiliaries wired wrong. In order to get to this, I had to drop the fuses down. And we had to do this with the power. We had to turn the power back on while we did this so we could test it, so we could figure out what's going on. You had to drop the fuses down, and we had to lay something underneath them so they didn't touch anything, and get the meter leads back there. And then the board where all the DC volts are coming out of is buried back behind the side of the contactors. You can't get a meter lead in there at all. It's impossible to work on. I don't know who stamped off on this, but it's impossible to work on. Like their normal drive cabinets are usually fine. Like the ones on the Walmarts and stuff, those things are awesome. Like this all integrated one was awful to work on. I mean, it's dangerous because you pretty much can't work on it energized, but you can't test it without it energized.
See, if you want me to share the pictures of what you're talking about, you're gonna have to resend them to me like now, because I think you sent them. I think you sent them in the group chat. No.
But no, we did that. Then we did 2 digital compressors on the Kimmel Motts rack, and on these Kimmel Motts racks that were swinging 45 pounds. And man, I came in the next day, and you couldn't even tell the difference. Or you couldn't even, it wasn't even the same rack. It went from going like this in like 200 plus cycles a day to no cycles.
Holy shit.
Straight line with 2 pound swing. Like instantly, like the whole rack is better.
2 pounds seems really ridiculous to me. I would expect more from you.
That wasn't even tuning it or like doing anything with the defrost. That was just slapping a compressor in that I blew up the boards before. I refuse to use the 4AOs with the digital compressors.
Why?
They backfeed voltage.
Share. I got it in a safe space now. Share. You see it?
Yep. Yeah, this is the drive cabinet. The contactors are in between.
Yeah, are behind here?
Yes.
What the fuck?
And that board in the upper top, that board goes back another 8 inches, and the back side of it, on the other side of the drive where the 460 comes in, is where all your voltage connections are for your wires going out and your inputs and outputs.
Well, I can see the because these look like what kind of contactors? The gray and red. What the hell are those?
The Siemens ones.
Yeah. So I can see the red, like the red label there, and then you can see where the 1, 2, 3.
Yeah.
I can't.
And then they're right above it is blanked off with an arc shield, and it's 1.5 inches too long for fluke meter leads to fit in anything. I was like, who designed this? Like, why? It normally they're fine, but like, and then there's like multiple different voltages on that board up there. Like, there's
I don't like that board.
that one shocks the shit out of you,
I know. That's why I don't like it.
and it's
I like-
exposed.
Yeah. No. That's why I don't like it. Like,
That
how come
had-
they could
Go ahead.
put the fuses like back here and then
Yeah.
just a little bit. You know what I mean? Because it has to connect up to here anyway, right? So why not just fucking move that up there?
So you can work on the damn thing.
Yeah, and have the contactors like somewhere nice.
So what they did is they flipped around the wiring on the auxiliaries. So every time it would go into drive, it would fault out. But there's no way to see what the fault is unless you get your meter lead on there to make sure that the board sees the input open or closed. There's nothing to tell you that it's open or closed. But you have to do it with a meter lead, and getting it in there is almost impossible without killing yourself.
Awful. It's absolutely awful.
But no, we did 6 of them, and I mean, I love taking old, beat up racks and just
Making them run pretty.
like making them just instantly. Those digital compressors, I'm hands down on an old store. Those things are the best money you could spend.
That or a VFD.
I don't know, man. Like I'm pretty sold on the digital stuff. Like the VFDs are okay, but like they always
But it's
they never put on the right compressor.
Well, no, because you give me cross feed about that. Because like sometimes you'll say, well, like, I don't like the digital because just give you a good solid pulse, pulse for your superheat or whatever.
If you have EPRs, hell yeah, digital.
No, okay, all right.
Yeah,
so
if you have no EPRs, then a VFD is way smoother when it's not at 5,000 ramp up and down. It might as well be a digital at that point.
It's a pulse with VFD stepper.
I mean, that's got to be bad on those. They can't be good.
Well, when we talked to Aswell, like he was saying like the because you got to remember what did he say? It's pulsing the transistors at like some kind of crazy is like 10,000 kilopulses at a fucking time or something like that.
Just really shoving it down.
Yeah, man. So it's got to cause some serious heat on the freaking drives. So that's what I'm saying. I've seen them up to 5,000. They'll literally go from 30 hertz up to 60 hertz within not even a half a second. It's just like freaking up there instantly,
Well, and then I see fans like that all the time, and then I'll see a 20-second ramp up and ramp down in the fan motor. What the hell is the point of putting it at 5,000 when your ramp up and ramp down's at 20%? How about move the ramp up?
I think, especially in the E2 and the E3, like the fan, like the accel and decel speed gets forgotten a lot.
Yeah, well, a lot of customer specs is 2,000.
That seems excessive for.
I just looked at I tuned a drive the other day, and it was at a store where they have a commissioning company come back around, and they recommissioned it and put it back to 2,000. I'm like, wow, you could really see when they commissioned the store, now it runs worse.
Be nice. I'm just kidding.
Mine had to be nice. The graph wasn't nice.
You proved my point.
I didn't have to. The E3 proved it for me. But no, that's I don't know. You ready to call for the night?
I'm smoked.
I'm smoked.
I'm gonna call me a turkey, dude. It's almost Thanksgiving and I'm fucking smoked already.
All right, guys. Thanks for listening.
See you next time, guys. Bye.
Have a good one. Bye.